Science, 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 science! Yeah!
Let's give it up for the 2024 Physics Phenomenon and Chemistry Circus!
Yeah!
I would like to introduce my co-host, all the way from Abilene Christian University, the Wizard of Wonders himself. Give it up for Sydney!
Let's go! Yeah! Come on, let's go! Whoa! Sydney, we have from Abilene Christian University, way far from Abilene, we have the Sage of Science Band! Yeah! Yeah, who wants to set things on fire? Yeah!
Who wants to take the derivative
Forget that. Let's blow stuff up! Yeah!
But before we do that, we're going to hear from our professor, Dr. Eisenhower.
Hey everybody, how's it going? Sounds like we're ready for the show, but before we do that, we have something important we need to talk about. What's wrong with what I'm doing right now compared to, say, maybe what Ben has? Yes? I don't have the proper outfit. What am I missing? I'm missing goggles. What am I missing? A hat. Sometimes a hat is helpful. Helmets can protect our heads. What else am I missing? I'm missing a lab coat. Excellent. Safety is super important with science. Sometimes the things we do can be... Yeah. Sometimes what you do can be dangerous. We are playing with fire. Is fire safe? No. Fire is dangerous. So we need to be careful. Do you get to do these experiments at home? No. Okay, so mom and dads, you heard them all say it. They won't do these at home, okay? All right, so just remember, these students who are doing these shows have practiced many times. They have the safety equipment. They have permission from their parents. We are not inside a house, so it's a little bit more safe out here, less likely for bad things to happen. So with that, please don't do these at home unless your mom and dad really say it's okay. All right? Thank you so much. And let's have some fun.
Yeah! Let's go!
All right, like Dr. I said, you won't try this at home, right? You're good kids,
Yeah, very
right?
good kids.
But
No.
But Sydney, is there somebody who hasn't been a good kid?
Yeah, we have a very bad kid here. He deserves some.
Well, I'm not the bad kid, but I do know something terrible's been going on in the physics department. Someone hasn't been doing his homework. Do you know what we do to people who don't do their homework? We do something terrible to them. We subject them to the bed of nails.
Yeah! Punishment!
Go ahead, get on the table. You know what you've done. That bed of nails. You don't believe me. Y'all think these are real nails? Try it out. Look at that. Sharp. Let's see what happens when we put it on him. Would you look at that? How's that make you feel?
I feel fine.
Okay, let's try something else. What if we put a cinder block on him? What if we did that? Go ahead, put the block on him. Alrighty, how does that make you feel?
I still feel fine.
Okay, things are not turning out how I wanted them to. What if we try What if we try tapping you a little bit? How's that make you feel?
I don't feel anything.
Really?
Really?
Wow. Okay, things are not going well. What if we put another cinder block on him? Would you look at that? Go ahead, put that on him. Alrighty, how does that make you feel?
Nothing. Nothing. I feel nothing.
Really?
Really?
I don't believe this guy. Would you look at that? How does that make you feel?
Still fine.
Really?
Oh yeah.
I don't get this. I really don't get this. Okay. We gotta try something else. Yeah, what if we do that? I need one volunteer from the crowd.
Okay. Go. Okay. Okay.
Need one volunteer.
Okay. Oh, just go on. Let's see. Okay.
Alrighty. How about now?
I'm doing fine.
Okay, I don't get what's going on. Like nothing seems to be working. We gotta try something else. We gotta try something a little bit more extreme. What if I break the cinder blocks? Let's see how it works. Alrighty, on the count of 3, I'm gonna need you all to help me. Count with me. 1, 2, 3.
Authy, how do you feel?
There's a bit of dirt in my face, but otherwise I'm doing fine.
I really don't get this. Like, what's going on? Like, I put 2 cinder blocks on him, put a kid on him. Like, I don't get it. Like, so much weight's being put on him. Surely he was hurt. Like, am I a wizard or something? I really don't know what's going on.
He's not a wizard! I'm Superman!
Well, he may not be Superman, but what this is showing us is some physics. Turns out if you apply a force to a really small point, there's a huge pressure that's exerted, which is why if you pop a balloon, or you're able to pop a balloon on one of these nails, but it turns out that when you take that force and spread it out across a whole bunch of points, then the pressure becomes less, which is why Authy was perfectly fine. It's cool physics.
All right, kids. Who wants to ride bikes? Do you like to ride bikes? Okay. Do you think it's harder to ride a bike to stay still on a bike? Is it harder to balance while you're still or when you're going? I think it's harder when you're still, like you might fall over. Well, Sydney here is going to show us some things about something called angular momentum. So let's give it up for Sydney.
Forget what he said. This is no angular momentum, no science. It is a magical wheel. Believe me. If you don't, look at this. Drop it. What do you think will happen? Okay. Oh, wait. That's not what I was expecting. Oh, I forgot something. The magical words. Spin the wheel. Say it with me. Spin the wheel. Yes. Is this magic? Oh, man. Fine. Wait. He's giving that a go around. Yes. No. Fine. You guys saw right through me. It is not magic. It is science. It is actually angular momentum. Well, the thing about angular momentum, right? Momentum is the property of things to stay in motion when they're in motion. And the same goes for spinning. And when you're spinning, you create like a force called a torque. And that counteracts gravity. And a lot of cool applications. Yeah, let me show Ben something. Spin the wheel. Okay, spin the wheel. Ooh, see that? Whoa. Oh, yes. Yes, it is science, an application of it. Because the thing about angular momentum, right? It is also dependent on the direction. Because what do you notice? When he turns the wheel, he goes the opposite direction, right? Yes, kid! Yes! And you guys know anything about, okay, one more time. Whoa! Can't believe this isn't magic. Like, why am I even wearing this hat? But it's okay. Let me show you one more cool thing. Have you guys ever seen, like, ballerinas? Yeah. Okay. I need a volunteer. Okay, you come, kid. Hurry up. Okay. Why don't you sit down? You're strong, right? Sit down. Okay. Keep it. Not right. Okay, spin you. Whoa! Very slowly. Whoa. Yes. That's another application of angular momentum. Okay, yes. It is cool. You know, there are a lot of cool applications of science.
Well, science is cool, but it also can be very dangerous, isn't it? You want to see something dangerous? Now we're gonna blow some cannons out! Now this is really dangerous, and you don't want to try this at home. But I'm like professional scientist. I can do this. So what we're gonna do is we're gonna shoot this rubber. Does anyone want to feel this? Alright, there you go. Yeah, that's pretty good, right? Alright, okay. So that's pretty hot. Then what we're gonna do is we're gonna put the lid on. This gonna blow up, and this is my theory. So this is hydrogen, and this is gonna be the fuel for shooting the cannon. And what we're gonna do is we're filling up the cannon. Dr. I is gonna help us. Dr. I gonna fill the hydrogen inside it. This is science, and it's a lot of effort. So now what we did is filling up this cannon with hydrogen. And here's... And this, what's going to happen is it's going to ignite the hydrogen. And what's going to happen is inside, it's going to burn all the hydrogen and make pressure to blow this thing up. Are you guys ready? Are you guys ready to blow it up? Are you ready? This is really loud, especially to those who are in like close. Cover your ears. Are you guys ready? Guys ready? 3, 2, 1. What's going on? I failed it. What? Do you want to try it? It's my finger issue. Who want to try it? No. I have to see what's going on inside. Is it connected? It looks good inside. I think magic's gonna happen. Can you say abracadabra?
Cover your ears.
3! Magic's gonna happen. 3, 2, 1. Oh. We're gonna make it. We got this. Wanna try? Sometimes science, you have to try again. Like you fail like 10 times, but if it makes the last time, then that's a success. You want my money back? Go to bed. This will work. 1, 2, 3. The one that. Okay, it's last time. 3, 2, 1. No.
All right, kids.
I guess it doesn't work. Okay. I guess no dangerous things anymore.
We're sorry, but it worked in practice. But when you don't know what's wrong, it's not safe to keep trying to go on. I'm sorry. So we don't know what's wrong with the device. We'll have to test some other things first. And we don't test with dangerous explosive gases. We test with safe, non-flammable things first. So, sorry, it worked in practice.
Next up, we're going to hear from Eric. Let's give it up for Eric. All right, who here likes magnets? If I haven't convinced you yet, I'm hoping that you will like magnets at the end of this. So, magnets can do all sorts of cool things. You can connect them together to build structures, you can levitate magnets above each other, and even the Earth's North and South Pole form just one giant magnet. So, there's another cool thing that magnets can do that I bet you don't know about. So, here we have a metal pipe. No reaction? Come on.
A metal pipe! Whoa!
Okay. And here I have a penny. This is a normal object, and I'm going to see what happens when I drop this on the pipe. What do you think is going to happen? Nothing. It's just a penny. But this is a magnet. What will a magnet do when it falls down a pipe? Now, a magnet shouldn't do anything crazy. This pipe isn't magnetic. There's no funny business here. So the magnet should just fall out as normal. So let's test it. What's happening? Okay, I must have done something wrong. The magnet just fell on through. Does anyone want to try for me? Okay, try it. Okay, come on, it should fall this time. Oh yeah, sure. Oh, you can have it. Okay, so what's going on here? So there's no magnets inside the pipe. No funny business going on. But when a magnet travels through metal,
it creates a little bit of electricity. This electricity creates a magnetic force that slightly pushes on the magnet. This has the effect of creating the magnet falling very slowly rather than just instantly like gravity. In conclusion, magnets are really cool. You know what else is really cool? Liquid nitrogen.
Wait. Stop! I think it's magic! Wait! I got something!
Sydney, what do you have there?
I got his magic staff!
What?
I'm fully a wizard! What? Yes! I'm gonna show you
Okay,
the force!
let's see if this is really magic.
Okay! Whoa!
I'm just kidding. I was just joking. It's not magic. But you know what is really cool? No, we're gonna watch Simon do some liquid nitrogen things. Here for Simon.
Hello guys, how are you doing tonight? Yeah! Alrighty, well, as I'm sure you've noticed, it's gotten a bit colder outside these past couple of weeks. And what happens when you get cold? You kind of start to shiver up, right? You kind of want to scrunch up and keep yourself warm. Well, guess what? We're not the only things that shrink up when we get cold. I gotta show you something really cool here. So this is something super duper cold. This is called liquid nitrogen. So nitrogen is a gas that is in the air all around us right now. However, normally it's a gas, but if you make it cold enough, it becomes a liquid. And it does some weird things when it's a liquid, because it's so cold. So I'm gonna show you this. I got a balloon right here, right? And notice how I said that when things get cold, they shrink up. So what do you think will happen when I put this balloon into something really cold, like liquid nitrogen? Let's find out. I can feel it getting a little smaller. Yeah, that's weird. Now it's heating up again. That's gonna inflate again. Whoa, that's cool, isn't it? Man, let's try this one more time. So if I put it in here, I could in theory fit a lot of balloons in here, couldn't I? If they're really small. How many balloons do you think I have in here right now? 1, 2, 7. Wow. I don't know. Let's see. We got one here. Let's see. We got. Oh. We got. Oh, there's some more in here. Oh, would you look at that? Oh, whoa. That's cool. Oh. Whoa. That's really cool. Now there's one more thing I want to show you guys that's super cool about liquid nitrogen. So notice, I have this, it's a little bouncy little racquetball thing. Notice if I throw this on the ground, it bounces up, right? I'm sure you've all seen that before, not super impressive. However, what do you think will happen to this bouncy ball when I put it in something really cold, like liquid nitrogen? Let's find out. Okay. Alrighty. What do you think will happen? Whoa! That's crazy! So why do you think that happens? Well, when things get cold, like the balloon, the pressure inside decreases. And so this causes the balloon to want to shrink up. And something similar happens with the racquetball. Things act weird when they're cold. So, I hope you guys enjoyed that.
Wow, Sydney, all this liquid nitrogen is making me a little cold. Oh,
Yeah. Whoa.
what do we have right here?
We got a fire, dude.
Let's hear from Emery.
Hi guys! Okay, raise your hand if you've been to the beach. Wow, that's awesome. Okay, when you're at the beach, what happens to the water? What is it doing? What does it look like? Shout it out. Yeah, it's a wave, right? But water's special because with water you can see the waves. But did you guys know that everything's actually a wave? Sound is a wave, light is a wave. So, with our special table here, once we light it on fire, we're actually able to see sound waves. The sound waves are inside of the box, and then you'll be able to see them in the flames. So what do you think is gonna happen if we play really calm music? Is it gonna be a calm wave or a crazy wave? What do you think? Calm wave. Let's see what happens. Do we have the mic? One moment. Yeah, it's underneath of it. Sorry. Okay. No, there's another cut. Sorry, guys. Okay. So this is a really calm song. It's not really doing anything, right? You can't really see any waves. I don't see anything. Okay, what do you think is gonna happen if we play a crazy song? It's gonna be a crazy wave. Play this song. It's not really working. Oh, there you go. So you can kind of see it as the beat's going, it's kind of making a wave. Just the wind. That's as loud as it goes, I'm sorry. There it goes. That's as loud as it goes. Yeah, so the bass, if you hear the bass of the song, that has a special frequency, and that frequency is why we're seeing it in the wave. Okay, that's it.
Let's hear it for Wade.
Yeah.
Wait, so Sydney, if everything's a wave, does that mean I'm a wave?
What do you mean?
Whoa! Whoa! Can you do the wave? All right, let's do the wave. Whoa! Okay. We gotta do that better. Let's try the wave again. Are you ready?
Okay.
Okay, be the wave. 1, 2, 3. Whoa! All right, now we're gonna hear from Athi.
What's up? Bit of energy. Now, electricity powers everything that we know pretty much. There's a giant screen behind you, that's all powered by electricity. We have a load of lights up here. All of those are powered by electricity. Even this microphone I'm using is powered by electricity. But I have a crazy idea. What would happen if we ran electricity through a pickle? Yes, please. Now, you may have to pay close attention. It's a little bit brighter than I was expecting, so you may have to look closely. But let's see what happens.
Anyone hungry?
I have the lovely smell of pickle juice all over my hands. Right. Are we ready? 3, 2, 1. Ooh. Give it a second.
All right, let's give it a sec.
Just give it a second. We'll see what happens.
Oh, do you see that, Authy? Whoa!
Trust me, it's a real pickle.
Hey, it must be magic.
Does anybody actually want to eat this pickle? Oh, that's it. Wow. I'm afraid for health and safety we're going to have to say no to that. But anyway, so the reason why this happens is that a pickle is filled with loads of little atoms of different types. Now, a really cool thing that happens with a load of different elements is that when you run electricity through atoms, they release photons, which is what we see as light. But there are different types of atoms, and they release different wavelengths, which correspond to different colors. For example, if we had a load of potassium loaded on here, you'd see a nice pink flame. But I wonder if there's anybody here who can tell me what atom it was that gave us this nice yellow color. Ooh, we have a chemist.
It's sodium. What's sodium? Does anyone know what sodium is? What do you think sodium is?
Bomb.
Bomb? Not a bomb. It's actually a little bit closer than that.
It's like something.
You're very close. Okay, do we like salt? Does everyone know what salt is? Yeah. Well, hey, that's got sodium in it, right? We love sodium. We love using sodium, and sodium is also in the pickle. All right, let's hear it for chemistry.
Hey guys! We are the ACU Chem Club, and my name's Angie.
And my name's Jack.
And tonight is going to be full of fun, old school learning with lots of explosions. Who's ready? Me too. Okay, but before we start, we have to make sure we're safe, because being safe is being cool.
Well, Angie, if we're gonna be safe, where's your lab coat?
Oops, let me go
Where's
grab
your
it.
lab coat? Okay, do you think we're ready to go now? No.
What do you think we're missing?
Someone say goggles? Am I missing goggles?
Does Jack need goggles?
Well, hey. I think I'm ready.
Okay, and I've heard some good guesses. I do need hair back.
A little intermission moment.
Okay, do you think we're all ready? Yeah! Okay, let's get this circus started! So first off, we have elephant toothpaste. Now, how much toothpaste do you guys use on your toothbrush every day? Like a little bit, right? Like a little bit. But how much do you think an elephant would need? Yeah, it's gonna need a lot of toothpaste. And my elephant back home has a lot of cavities, and he doesn't brush his teeth. So we're gonna need to make a lot of toothpaste.
All right, so when in making this toothpaste, we're gonna have some pretty cool explosions. And part of this explosion is chemical hydrogen peroxide. And this hydrogen peroxide is gonna make something called oxygen. Now, oxygen's gonna wanna leave these flats here on this yellow table, but before it can do it, the dish is gonna grab hold on that oxygen. It's gonna make a big boom. Y'all think it's gonna be the biggest one? How about this one? What about this one? Yeah? Let's do this first one. Yeah, that was pretty cool. Okay, what about the middle one? Let's get it. Not as big, but hey, it's a cool color. All right, our last, give me the biggest one. Let's hear some cheers if you can answer me the biggest one. Oh. Well, hey, let's give a round of applause for them doing this.
Thank you guys for helping us make some toothpaste. Okay, now our next experiment is pretty lit. So, and it's also gonna be really cold. Do y'all know how cold dry ice is? Do you know what dry ice is? I think I heard it. I think it's negative 109 degrees. That's colder than Antarctica. So like no penguins can live in dry ice. It's so cold.
Okay, so the science behind this one is pretty interesting. We're gonna crush up some magnesium. Does anyone know what magnesium is? Okay, so magnesium's a metal and it'll combust in the air around us at really, really hot temperatures. Now that's gonna be really hard to do by normal means, but if we use the dry ice, which has something called carbon dioxide coming off of it, it's gonna bind to the magnesium and it's gonna allow it to combust. Now I will tell you that if this is done correctly, it's gonna produce a big white light. So if that's gonna bother you, close your eyes. But let's see what happens.
Thank you.
Let's see.
How about that?
Oh my goodness. Good job.
Let's give it up a round of applause for our fire and ice group.
Okay, for our next experiment, we're gonna need one of my foods. Can y'all guess what it is? I'll give you a hint.
Okay, so for this experiment, we're gonna blow up a gummy bear. Y'all ready? Real quick, before we do it, I need to explain something to y'all. We're gonna use something called potassium chlorate, which is just a fancy big chemical, but it's gonna produce some gas, and when this gas binds to the gummy bear, it's gonna cause a big explosion. Are y'all ready for a big explosion?
Yeah!
We gotta wait, gotta get hot enough. Almost there. Hold it. Hold it. Look at that gummy bear dance. Look at it go.
It's so bright! Yeah! Okay, give it up for our gummy bear experiment. Okay, for this experiment, I need to know, how many of you have dogs at home? Okay. Now I need y'all to give me your best bark. Go. Okay. Those were some pretty good barks, but I think we can make an even bigger bark with our experiment.
Okay, so y'all heard me talk about carbon dioxide earlier, right? Okay, so this time we're gonna use something a little different. We're gonna use carbon disulfide. Now this is usually a liquid, but it's gonna evaporate around, and this gas is gonna be heavier than air. And so what is it gonna do? It's gonna sink into our graduated cylinders here, and then we're gonna use something really scary. We're gonna use white phosphorus. Now white phosphorus you gotta be real careful with, because it's gonna combust on its own without any external flames. No heating, no nothing. So we're gonna see what happens. Our careful scientists here applying the phosphorus. Now this might take a minute because we have to let the phosphorus dry.
Jack, do you have a good dog joke?
Do I have a good dog joke? Are you kidding me? Of course I have a good dog joke. Y'all want to hear a good dog joke? Okay, what type of coat does a dog wear? A lab coat. What about you, Angie? You got any dog jokes?
I do have one. Okay, what's the most popular dog breed among magicians? It's a Labrador.
That's pretty good. I like that one. Okay, y'all. I think we're getting close. We just gotta be ready, okay?
Which one do you think is gonna have the bigger bark?
How about the one on the right? You think the one on the right?
How about that one?
How about the one on the left? Sounds like the left one's gonna win.
I think
don't
the
know.
right one's gonna win. No. These dogs are taking their time. No, there's no dogs in there.
We're gonna rub the white phosphorus, see if we can get it to go a little bit quicker. Angie, what type of dog do you have?
I have a pit bull dog.
Pickle dog.
A pickle dog. No, I have a pit bull. What kind of dog do you have?
I have a corgi. Yeah, corgis, am I right?
cute.
They're awesome.
Corgis are cute.
I wish she was here right now. Wiener dog? Is that what you have? Whoa!
Oh!
There's one of our dogs. They
There's
showed
one
up.
of the dogs. That one was pretty loud, wasn't it? Yeah, make sure you stay behind the line, kids. Let's see if the other one does it.
All right, everyone get ready. It can happen at any moment.
Exactly.
Stay focused. Okay, we're gonna add a little bit more phosphorus here. We're gonna get this dog to bark, don't worry.
Oh, yeah. This is science, guys. Sometimes we just gotta wait. Okay, well, while we wait for the dog to bark, we're gonna start our next experiment.
Okay, who knows what a genie is? Have you seen Aladdin before? Okay. We're gonna do something called a genie in a bottle. And the way this is gonna work is we're gonna take a very flammable liquid and we're gonna shake it up real nice and good. And hopefully that liquid's gonna turn into a gas. And that gas is gonna be really flammable. And you're gonna see what happens when we throw a match inside of it.
So we have a special volunteer, Dr. Ricks. And he's gonna be able to get 3 wishes. Well, maybe, I don't know. We'll see what the genie says. Okay, Dr. Ricks. What is your first wish?
My first wish is that maybe I could get like a couple of $1 million.
Okay, let's see what the genie has to say. Which denied. Your wish was denied. Let's see. Okay, what would your second wish be, Dr. Ricks?
I want one of the new Ferrari supercars.
Let's see what the genie has to say. Oh, wish denied. Okay. He only gets 3 wishes. Let's see. What's your third wish, Dr. Ricks?
What's my third wish? My third wish is that you would graduate.
Let's see what the genie has to say about that. Wish granted. Yay! What's your 4th wish, Dr. Ricks? Looks like I'm gonna graduate, Dr. Ricks.
Looks like it.
I guess
I think she's gonna graduate anyway, though. She'll be just fine.
Let's give it up for our genie in the bottle, guys. Okay, so this next experiment is something pretty similar to the genie in a bottle, except we're gonna have one slight variation to this. We're gonna, instead of evaporating our flammable liquid, we're gonna let it still be a liquid. How many of y'all seen Star Wars? Yeah?
So here at ACU, we get to make our own lightsabers in class.
So, let's see if we can get our first lightsaber going. Are y'all ready?
Ready?
Let's go get it. Oh!
Whoa!
I know.
That's a pretty cool lightsaber.
Now, sometimes if we burn things, they can burn different colors. Do y'all want to see a lightsaber duel? Y'all want to see them fight? All right, there's green, there's our Jedi. What about our Sith? Whoa! Look
Let
at
the
that!
war commence!
Who's gonna win?
Sit! 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 Oh! No! Yeah!
Let's give it up for Flaming Swords, guys.
Okay, who here likes Doctor Strange? So we got a really good deal with him, and we were able to bring his assistant down so that she could make a portal for us. All right. Let's see if Alexis can make a portal for us. No, you cannot go through the portal. Let's see. Whoa!
Look at that. I don't know if I would want to go through that portal.
I don't know if I would want to
It's
either.
scary.
Let's give it up for Alexis! Okay, have any of y'all changed a light bulb or seen your parents change a light bulb? Because what do you usually have to do before you change the light bulb? You gotta turn the light off. But why do you have to do that?
So typically, when you have something that's giving off light, it's also giving off heat. That's why you don't really want to take a light bulb out when it's still on. It's going to hurt your hand. But if we do some cool chemistry stuff, we can make light without heat, and we can do it with liquids. And today, we're going to show you a special scenario with something called luminol. Take it away, Drew. Ain't that neat?
So we made that all light up with just liquid. Jack, it's looking a little dark out here. Do you think we could light it up a little bit?
I think we can. All right, guys. What color is ACU?
Purple!
I couldn't hear you. What is it? It's purple. Y'all want to see some purple? Go Wildcats.
Go Wildcats! Okay, now I'm not a big fan of bugs, but my favorite bug is a firefly.
Is it a firefly? You said firefly? Well, I've got something special for you and everyone else today. We're gonna make some fireflies of our own, but before we do that, we need to make something that we need in order to make our fireflies. And that's gonna be called chromium oxide. So everyone get ready, pay attention, watch carefully.
Yes, Toby. At least. At least.
1 second.
Here we go, y'all ready? Get ready.
You're ready to see fireflies.
It's going. There it goes.
Okay, there it goes.
Oh, there it goes. Look, look.
And this is just the first step, guys.
What do you think, Angie? Mini volcano?
Yeah. It's kind of like we're in Hawaii. Okay, so what's gonna happen after our mini volcano?
Well, currently what's happening is we're combusting this substance, and this substance is going to make something called chromium oxide. Now, this chromium oxide, okay, is going to be able to combine with something called ammonia. What you really need to know is that it's going to go boom. It's going to go boom.
Okay, let's see.
We're just getting it hot here. We're almost ready.
Let's see. Look at the fireflies!
Look at them go.
Ooh, yeah! Give it up for our fireflies! Okay, for the next experiment, I'm gonna need y'all to guess what my favorite holiday is. Can you guess? I'm gonna give y'all one guess. I think I heard it. My favorite holiday is 4th of July. Come on. And what's everyone's favorite part about 4th of July? The fireworks. You're right.
So, while our awesome, beautiful scientists here are getting ready, let me tell you a little bit about this. Now, who remembers the gummy bear experiment we did at the very beginning? Right? Okay, you might have remembered me. I said something called potassium chlorate. Now, essentially, we're gonna do the same thing here, and we're gonna have the same type of combustion, but instead of a gummy bear, we have different types of sugars mixed up with different things. And so hopefully, we're gonna get different colors out of these combustions. Angie, what's your favorite color?
My favorite color is blue.
Not purple.
Oh, it probably should be purple. I don't know.
You're an ACU Wildcat. It's supposed to be purple. My favorite color is purple.
But I have purple hair, so it makes up for the fact that I love blue.
I guess.
This ain't a wig. This is my, no. See, I have curly hair and I have a curly purple extension.
All natural.
That's not a wig.
Okay, are y'all ready?
Okay,
Look
who's
this
ready?
way, get ready.
Let's look. Let's see what colors they make. Whoa!
Whoa. Whose favorite color was red? Yeah? Okay, how about this next one?
Let's see. Ooh.
That one's cool. I like that one.
That one was pretty.
All right, here we go. Last
like
one.
yellow.
What color do you think it's gonna be?
Let's see. Oh.
What do you think? Is it green? Is it blue? I'm hearing green. Hey, let's give it up for fireworks, y'all.
Okay, and for our last chemistry presentation of the night, we're going to be doing hydrogen balloons. This is the one with the big explosion, so if you don't like loud noises, make sure to cover your ears, okay?
All right, while they're getting ready, when the physics group was up here, they talked about hydrogen a little bit, right? No? Hydrogen is a great source of energy. In fact, it's a really good fuel and it's typically clean. However, the problem is that it tends to explode really easily. So we don't want to always use it for fuel. Are y'all ready for a big explosion?
Yeah! Oh.
I don't know if that was hydrogen. Was that air?
That was
I don't know. I think it could get
air.
bigger.
Let's see if the next one's bigger. I was ready for a big explosion.
I was ready for a big explosion.
Let's see.
It's a little bigger.
I am not impressed. Let's see, maybe the yellow balloon will give a bigger pop? Let's see if this one's any bigger. Oh my goodness. Okay, let's see. Red balloon. Whoa!
That one was pretty cool.
That one's awesome!
Okay, y'all, cover your ears, okay? It's gonna get loud.
This one's gonna get loud.
Oh.
Ooh.
Cover your ears again.
Let's see. Wow!
It's like fireballs.
It is.
All right, it's the last one. Y'all ready?
Okay, time for the last balloon of the night.
All right, guys, thank you so much for coming. We have still more to come, so don't go anywhere. I'm gonna hand it back off to our physics department. I've been Jack.
And I'm Angie.
Thank you.
Thank you!
Yes, the chemistry department made some explosions. But do you think the physicists wouldn't go out of a bang? We got one more for you. Yeah.
All right, this is going to be our last explosion of the night, last event of the night. So remember what happened when we had something that got colder? It got smaller, right? But if we make something warmer, then it gets bigger. So let's see what happens when we trap liquid inside this bottle.
Cover your ears, kids. It's gonna be a loud noise. Okay. Oh, God, whoa. Okay.
So this is not a super fast one. It takes about 30 seconds to get too hot, but it can go off at any time.
Yeah.
Thank you for coming. Y'all have a great homecoming.
Let's go!